So can everybody hear me? All right, good. So I'm going to do a talk on attacking .NET web services. This is more of a talk kind of about my general process on how I kind of go through some of these things. As she said, I am Ryan Wincey. I work for Securifera. I do a lot of bug hunting where we do primarily red team work for the Navy. I have my history here, some advisories that I've found, some of the CVEs I've gotten when I've looked for certain types of bugs, as well as a link here to the last talk I gave that's kind of similar to this here at BSides in 2015. It was a similar kind of walkthrough, but more for memory corruption type bugs, where this one's going to be more web services, kind of the newer type things that are out, since memory corruption seems to be kind of going away in a certain regard. All right, so kind of to go through what I mentioned a second ago. So this talk is going to be kind of more process related in regards to, hey, I had a target that we got assigned to. We're going to be doing a kind of white box code review of the software here. Our customer kind of gave us a couple weeks. They said, hey, we want you to find some vulnerabilities. We want you to prove impact. Tell us why we care. So as we walk through this, that's kind of the goals here. We're going to be looking for vulnerabilities, interesting things, as well as kind of displaying some of the tools that we had to do or to use to do so. And then at the end of it, I'm going to show, okay, based on some of these bugs that we might have found, here's some of the ways that you would exploit them to kind of show impact. A few of the tools that I've noted that I'll go through here. Mostly for reversing and debugging, as well as kind of the exploit phase. We got Inspy and .peek. They're going to be primarily for the .NET reversing, as well as the debugging. And then the last, of course, is Burp Suite. That's going to help us kind of walk through some of the web exploits and sending those packets to make sure that we can actually see some effects. So our target here, this is a piece of software that's put out by Siemens Healthineers. It's called Syngodynamics. We had this on a customer target. It's used primarily for doing kind of cardiovascular imaging. But when you look behind the scenes, it's really just kind of a thin wrapper around a whole bunch of .NET web services. So that's kind of the basis of this whole talk. We're going to be using it as kind of our example on what you would look at if you were trying to do something similar. All right, so again, kind of giving context here, if you were given this task, one of the primary things you're gonna have to do first is kind of get access to the software. So in our example, we were kind of given, access to these systems that has the software installed. So one of the things we like to do is try to model this environment outside of the system. So one of the things that you would do in this scenario, if you couldn't get access to the software, is grab what you can off of that target, try to get it over to your environment, try to model it yourself on a similar, VM or something of the like. Make sure you try to get it configured and that sort of thing. So some of the details you'll see later on here is kind of going through that process of here's what it would be like if you were able to actually get the software and how to try to get it up running yourself, so you can go through and actually try to look for vulnerabilities and debug through it. So one of the first things when you're looking at, say, a .NET web application, unlike, a regular service binary application where it's super simple and you're like, hey, here's this application that's running, I know where the code is, and you start reversing it. With web services, it's not as clear cut. First, you kind of have to find it. So one of the easier places to kind of start that path there of where to look is you start looking in the configuration files for IIS. One of the first places to look here is your inet serve config. As you can see here, it's going to start telling you where on disk some of these things are installed to start prodding further. That leads you to your web configs for the particular application. So you can see here in the bottom right. When you start looking there, it starts kind of giving you ideas of here's the particular classes, here's the different paths they're going to be mapped to kind of give you a better idea of, hey, this is where I need to start looking. These are the places I need to start investigating to see if I can track down where the code is for this web application. So if you follow those through and you start looking on disk where the config files are pointing, we take example one right here is called data transfer services. You're going to find a whole bunch of these files that end in a .svc. So it's starting to sound like web services. You open one up and you start seeing some definitions here that say assembly, and it has pretty generic names like data transfer services, but it doesn't look like a particular file. So you're getting a little closer, but you're still not kind of exactly what this file is or where it is, but you're on the right track. So in that config file, I reference something called an assembly. So if you look up what assemblies are in .NET, here's a quick kind of explanation from Microsoft. It tells you assemblies are typically an exe or a DLL that's going to be in your .NET application. So you're in that directory that we saw earlier. So you start poking around, see if you can actually find any DLLs or executables in that same directory structure. So you'll see here, I just brought up search in that same directory that had all the service files, and just start looking for DLLs and executables. They're in that actual directory structure there. And you'll see pretty quickly the name of that service that we looked for in the config file. There's a DLL that's named the same thing. So there's a good chance this is exactly the file we're looking for. So at this point, you kind of want to crack that open, and you want to start looking at, what's in this DLL? Is this actually the code for the web service that I'm looking for, and what's that going to look like? So one of the first tools that we're going to show here is JetBrains .peek. .peek is something you can load a DLL into if it's .NET, and it will actually reverse that for you. It'll show you all the code that you need, and you can actually start looking at it. One of the nice things about JetBrains that makes it a little bit different than some of its other alternatives is it also allows you to generate PDBs. This is something that will come in handy later when we start talking about debugging. Could be useful, something we might have to have going forward. As I mentioned, one of the main alternatives that a lot of other folks use is called the Inspy. It looks almost identical. The developer, I assume, just kind of used JetBrains probably as a template for what they wanted to look like. This is open source. A lot of similar functionality. The big difference between this and JetBrains is that this allows you to actually do debugging, which is going to be very useful when you get to the part where you actually want to run your code and see what you can do with it. But yeah, otherwise you can see, it's almost identical. In this particular example, we're looking at our data transfer services that we were looking for earlier. This is a class here. And one of the interesting things to note I have brought up here is there's something called contracts when it comes to these web services. And if you're very familiar with coding in general and the idea of things like interfaces, a contract is kind of a similar idea where it says, okay, here's the functions that a service would actually expose. Think of it as the different things that you could call through your web service. So this is going to be very important to us when we start trying to actually utilize our web service and the different entry points that we're going to start looking at when we start reverse engineering. So again, we got a handful here, and at this point we're going to start kind of digging deeper and pick a couple out and start seeing how would you actually look at the code. Where do you go after you have a contract or an interface to actually start doing something useful? All right, so we have our contract here, and I think in this example we're using JetBrains, .peek, but Inspy does the same thing. They have all the same functionality. So if you were to click on one of your contracts here, click right on over to go to implementation, and it'll actually bring up the source code for you, and you can start looking through it. This particular example, you start seeing some useful things. Has to do with files, which is one of the key indications of things I like to look for when you're looking for web services. Some of your common vulnerabilities are like file uploads, file writes, those types of things. So already this kind of jumps out to me as something that could be interesting to look into. This is the later part of that same function, super small. As you can see here, it opens up a file, it actually reads it, and then it just passes it straight back. So this is already kind of sounding interesting. This might be a possible, local file read just straight from, remote procedure call, which is, your entry points into this web service. So another thing I meant to point out here that also is interesting that I wasn't super familiar with at the time is you start actually looking through some of this code. One of the things that looks interesting is that one of the arguments that you have here to this function, our file name that we actually control, is passed into this function called path combine. It takes in, what looks to be some kind of configuration path to the root, and then our file name creates, a combination of that through path combine, and then it passes it on to actually be read. So at first glance, you probably think, okay, well, that sounds normal, right? Like you're going to have one argument that you don't control, one that you do. They're going to safely combine those together. No big deal. How's there any kind of vulnerabilities here? But we skip forward here and you actually look at this article that Praetorian put out a year or two ago. They found a very interesting effect here, which was path combine actually will take both of those parameters, and if you have one that's a absolute path, it will just ignore the other one. So super interesting, because now we almost have the equivalent of a directory traversal or something similar, where we can arbitrarily control the path to whatever this argument that comes in. So we got lucky here, and that we have what we thought. This is a local file include. So pretty interesting, right? You get all excited, and you're like, okay, this could be interesting. All right, so if we skip back to our services here, when we were looking for the code earlier, usually once I get to this point where I'm like, okay, there could be an interesting finding. I really want to see if this is real. Now you actually want to start constructing some kind of POC, some kind of payload, so you can actually confirm your findings, right? So how do we get to the point where I'm looking at code in this weird, web services.net stuff? How do I convert this on over so that I can start sending packets? Because at this point, I have no clue how to put that together. All I see is service contracts. I don't know what that is, how that works. So if we take a look at some of these, naming, terminologies or whatever, think of it here as our WW root, and then of course into our directory here. That in this example, it's data transfer services. Our WW root, that's going to be just like a regular website, right? Starting there at root. Everything behind it's your URL. So if we're going to just guess and say, okay, how could I get to one of these services? I'm probably just going to type in data transfer services, and I'm going to pick one of these SVC files to see if I can get there. So here's an example. We picked common services.svc, put in our data transfer services, and we're going to put it in our browser and just see what comes up. What's the service look like with .NET? So this is probably going to be your most common example of what that would look like. It's going to say service. It's going to not tell you much else. It's going to say your metadata is disabled. And you're like, okay, well, that doesn't tell me much. How do I actually use any of these functions that we were looking at? How do I send a packet to this? I don't understand. So the cool thing about this is it actually kind of tells you the answer. It says, okay, well, if you actually want to enable metadata, aka get more information about what's going on here, go into the config file, you put in this new configuration point, and it's going to start showing you more information. So we're going to navigate over to that same directory we're in as our SVC. We're going to open up the web config. We're going to turn on the metadata here. You'll see it's highlighted. You can do it for both HTTP, HTTPS if it's enabled. Now we're going to see what happens. All right, so if we go back, now we get this new thing. Okay, so it's changed. Still not super interesting. I don't know what a WSDL is. I don't know how to get a request out of this, but something's happened. Something's changed, and hopefully we can start getting more information on our next step. So if you click on that link that it shows a WSDL, you'll see here we have some kind of protocol specification. Kind of shows, okay, these are all the things that this particular service exposes and all the different ways that you can interact with it. It's all in XML. Most of us can't read this. I don't know what this means. So we want to figure out how can I convert this into something useful, because I want to start creating web requests. I want to actually send something to these endpoints. I want to see if I can read a file. Luckily, Burp has a nice big plugin here called WSDLer. You download this through Extender. You can pass over any of these XML WSDLs, and they'll actually parse it for us. Just like so. And it'll start showing, okay, so we we go to that page, it's going to show it here in our history. And then if we parse on over to WSDL and say parse WSDL, then it's going to bring up this other page under the extension. It's going to show us all the different operations here that we can use. And then very conveniently below it, it actually gives us a template here, a little example request on how to actually get to it. So it's super nice. You'll see here we have one highlighted here, that download patch update. Now I have a really simple way of actually just going in here, and I can pass this straight to repeater, and I have an example for how to send this request. So at this point, I pass this request over to repeater. As you can see below, you're actually seeing the name of our function there. It looks very similar, kind of the contract that we were looking at earlier. It takes this update ID, it takes the file name, and that's it. So super straightforward, got everything done for us. So let's just go straight to it and actually just pass in a full path and see if what we want actually works. So sure enough, see over here on the right, I pass the path to etc host on Windows, and we actually get etc host. Super interesting. This seems like a big deal. All right. So it's a lot of times at this point, we've actually, done something interesting, but I also kind of want to get to the point where, let's say it didn't work the first time, or we actually get to these other functions that we actually want to start digging into, right? Or let's say I didn't know what that first argument was, and if, I needed something specific to it, I actually want to figure that out. So at this point, I'm kind of gonna dive into the next piece of, let's say we actually needed to debug it, right? So it didn't work the first time. I actually need to see in code why it broke and how to go further. So we're actually going to start trying to figure out how to debug. All right, so now if we switch over to Inspy, we've got JetBrains' .peak's big brother or little brother, the brother, whatever, right? They have a debug menu here. Inside it actually has the ability to attach to a process. So if we bring that up, you can see listed here any of the IIS processes that are running currently. If you don't see one, you can send a request and it'll pop up. One of the interesting things to point out here at the bottom here, it kind of gives you a little hint. If you don't see anything after you sent that request, it wants to remind you there is a chance that you could have architecture issues, right? So like if you have inside IIS, this is a 32-bit application and you're running 64-bit Inspy, you're not going to see anything. And so you have to make sure that you know exactly what architecture your IIS is running at. So to kind of give you a little help there if you ever end up there, because I did in this particular scenario, you can go to your application pools configuration for IIS. You can click through advanced settings here, and you'll have this nice little configuration point. It'll tell you whether or not you want to enable 32-bit or not. If you do, you can click on that and kind of define how that particular application is running, and then run it with the appropriate architecture. All right, so now we've got debugger running. And so you're like, all right, so I'm about to start seeing some, ability to step through my code. And unfortunately, you see this error. So typically when you have a debugger running, when you put a breakpoint on the far left there, that'll turn into a little solid red dot. If it doesn't, and it gives you that little, sign that says there's a problem, you load over it. Basically, it's telling you, hey, yeah, I'd love to debug for you, but I don't have any symbols. So this is where we were talking about earlier, the differences between Inspy and .peak. So luckily with .peak, you can then go and generate those symbols. It'll create a PDB, and then you can actually take that file and you can drop it in to wherever your service is, and then it'll have its symbols, and you can actually start debugging. Here's a slide that kind of goes through that process. So open up .peak, go to the top of your project here, generate your PDB, drop it in, and you should be good to go. All right. So now, if we were to step through the exact same function as before, and we're trying to debug through it, you'll see here, we're actually stopped here at our particular line where it's taking in our path combined. It's taking in the parameter we control along with what should be the right directory. And we can verify right now down here the line is following it, it's going to check whether or not that file exists. And we can see in our debugger that it's actually our full path rather than the right one. So this kind of gives us more granularity again. So like if we really want to dig into something else, being able to have the debugger handy on an application that's already running that we don't have source code for, these tools make it very simple to make it seem like we do, and we're actually the developer, even though we're not. For fun here, I've kind of highlighted the little bug there for, both of the examples here where it's taking in path combined and using that in a way it shouldn't. All right, so we've verified our bug. We've stepped through our bug. What's kind of the next steps here, when you're doing some kind of source code audit and you're like, okay, I got something interesting. Is this just a one-time thing, or do they do this all over the place because they don't know about this? So if you're in Linux, you'd probably just start grepping stuff, right? Well, in IIS and Windows environments, they have a similar tool, grepwin. And so one of the things I like to do is just say, okay, let's dump that source code because we already know that both the Inspy and .p can do that. So we'll dump all the source code, and then we'll just bring up the equivalent of grep on Windows, and we'll just pop in path.combine, right? We're going to look through the whole source code base here and see, all right, how many times does it use it? Is there a chance that it's doing similar things on other endpoints that we can also get to? So this is kind of the quick and dirty, easy way of doing it. Not super efficient because we still have to go through 50 some odd, examples of this. But as you can see at the bottom here, there's a lot of examples. So there's a good chance that they're doing it more than once. Or say you want to get smart. So nowadays, there's other tools out there. SimGrip's a good example, right? SimGrip, think of it as the same idea as grep, but it starts adding a lot more kind of programmatic kind of analysis to the code that's in the background when you're grepping. So say I want to, look for this thing, but only when this happens, and this has to either be in a class or a function or has to return this particular thing. Allows you to add a lot of logic to it to actually find more specific things and kind of parse out the stuff you don't care about. So here's an example of, if you were using a SimGrep rule to do what we want to do. So in this particular example, I'm looking for path combined, but the interesting thing is I want to make sure that the argument that it's taking comes in directly from the function. So let's say, okay, we have our function, has an argument, and that gets passed straight into path combined. So super simple, like not a hard thing. It should be able to find that, right? Unfortunately, for me, this didn't work. And so this took a little while of figuring out, okay, why doesn't SimGrep work? This should be super basic. Okay, it supports .NET, but I'm only getting 2 findings where grep is getting like 40. And I went and manually checked, and sure enough, it should have found more things. So why is this not working for this particular example? Well, for me, SimGrep's pretty new, and so it still has some limitations. This is just more of a fun thing to throw in here. If your function happens to use these things called lambdas in .NET, which I also learned about for the first time, it doesn't work in taint mode. So if we were to go back and actually look at some of our code here, we'll show you this one example. I went right past it. Yeah, I know you all don't really care too much, but right here at the top of every one of their functions, they have these weird lambdas, which is basically for logging purposes. But the gist of it is they have their function, they call another function, and then it has a callback that actually has their vulnerable code in it. So unfortunately with SimGrep, they are blind to everything that's happening inside this lambda. So unfortunately for us, we couldn't use SimGrep. So back to the boring stuff. All right, so moving forward, we have grepwin, we have all these examples of things we want to look at. Let's start looking at some of the other things that they could be doing with path.combine that we might care about. Up until this point, we have the one, it's a file read. Is there anything else? So we're looking at a different one here. It's called write preferences. Takes our path combined, and instead of reading, this one does a write. So that seems important. If I can control path to wherever I want, it seems like I might be able to write a file anywhere I want. Sounds like fun. What can we do with that? So we go through the same process we went to before. We go to WizBlur, we create a request. We pick, a nice fun place to write to. We're just gonna go Windows temp. we get a response that looks like it might have actually worked. And if we go in there and look, sure enough, our file's there along with the content. And so arbitrary place to write, arbitrary content to write. So this seems fun and very bad. What else? All right, so here's another one. Very similar to the other one, except instead, when it takes our file path in, it tries to read it as an XML document. So not as useful, similar, but what can we do with something like this? Is this still bad? So it turns out you can actually put in SMB Pass here. So even though it doesn't matter if you can actually read it, doesn't matter if it's something useful that's going to come back to us, we can actually point it wherever we want, which you can actually point it, like I said, to an IP address that's anywhere else. Think of this kind of like a SSRF vulnerability. So we're going to say, hey, I'm going to give you a place that's some other network, and I'm going to say, all right, go out there and look for this file. And it's going to go out and it's going to try. And the interesting thing about it with SMB is it's also going to try to authenticate, which is fun, because it's going to say, hey, since I'm authenticating, I'm going to give you my NTLM hash, and you can capture that. So also bad. All right. So we've used a few different examples of the different types of bugs that we've all found just with this one path.combine. And we kind of alluded to some of the interesting things you can do. So now it's like, okay, well, let's take this a little further, right? Our customers are going to want to see actual impact. So we need to actually write up some exploits and say, okay, what's the cool things we can do with an arbitrary file read, an arbitrary file write, and this SSRF. All right. So since this is a website, one of the things that we like to try to read that's interesting to us is you can actually get to the web config file for the particular web service. So the reason this is interesting is because if you read that web config file, a lot of times they use these decryption keys and these validation keys. Interesting thing about a decryption key and a validation key is IIS uses these to do encryption for a lot of interesting variables that get passed back and forth. With IIS, one of the most interesting ones that we care about is that it uses things called view state. So if the particular application uses a view state, it encrypts it. On the back end, it's actually decrypting that using common serialization libraries that can then be manipulated to get code execution. So basically, if you get the decryption key, the validation key, very bad. Common tool here that's used for this type of thing is called YSO Serialnet. Super simple. You download it. If you have all the right parameters here that we just pointed at, so you got our decryption keys, validation keys. You put in the location of where this is going to happen, the URL. It'll generate a nice little payload for you, and then all you have to do at this point is find a endpoint that takes view state. You plug this in, and pretty much whatever you have here under our command, it's going to run on the back end. So you get code execution right away. Very bad. So here's an example of what that would look like if you were looking in Burp and you're actually looking at your request. You would find your view state, you just copy in that payload straight in there and fire it off. All right, so moving on to our arbitrary file write. So probably one of the most common things that people do when they can write to a web, application directory is they start putting up things like web shells. So for those that aren't familiar, a web shell is pretty much just a web page that has code in it that allows you to execute arbitrary code. So you would use some kind of vulnerability, some kind of something to be able to upload that to the website. Then at that point, whenever you make additional requests to that particular website endpoint that you just uploaded, now you can run whatever commands you want. So if we take our file write vulnerability that we just talked about, we can tell, okay, I want you to go to our www root. I want you to put in this ASPX endpoint. And then this particular one takes base 64, which is even easier for us, because that way we could send binary if we really wanted to. It's going to make sure that's all sent nicely, packaged up, encoded, and then de-encoded on the other side, or decoded. Here we go. So now if we were to navigate to our aa.aspx, it has our nice little code over there that's going to take whatever command we put in, and we're going to execute it. And we'll see that this particular one's running as a service account that actually comes prepackaged with this web service. All right, moving on to the last thing here. So let's say again that we didn't have the more extreme reads and writes. All we have is the ability to pass it a path and it's going to go look for it. So we have our SSRF. The tool here that I don't think I explained originally to catch these things is called Responder. So let's say that you have Responder, it's listening out in the cloud. It's going to catch that SMB connection that's coming in. You see our hash here. Okay, so now what would I do with that? Okay, so that brings in Hashcat. So Hashcat, most people know, is kind of the successor to John the Ripper, whatnot. Does a lot of cracking of hashes using GPUs rather than CPUs, but I assume it does both. But the gist of it is we take in our NTLM hash. They have a nice little chart here that says, okay, here's the hash type you have. You can have the particular ID you have so that you can actually put that into your command here to run. You go download it. You put your hash in a file. You say, okay, it's this particular hash type. Kick it off. And hopefully you have a really big file of passwords or dictionary that you're going to run this again and hope that they did a really poor job with their password complexity. Yay, so lucky for us, we guessed it. So they just did a keyboard walk, which we see a lot of these. So using Hashcat, we were able to actually get that password out. And so, okay, well now we have a password. What can we do with that? Well, that's super easy, right? So since it's a web service, it's going to have RDP open. We already know the user that came in off our hash, or off of our collection of the hash. We now have the password, login, also RCE. All right, so that kind of wraps up the whole discovery, the process, the exploitation. Now you're at the point where, okay, I told someone about this, they freaked out, what do I do, right? They're like, I don't know how to talk to this vendor about how to get these fixed. Like, they just gave us the software, they said it's great and wonderful. What do we do? You say, okay, well, we've done this before. We can reach out to them, we can disclose this to them. And so a lot of times this doesn't work out that great, but sometimes with bigger companies that it does. So what's that look like? So if you're the researcher and you're trying to figure out the steps to take, these are kind of our first things to look for, right? Go see if that particular company has a disclosure program, right? So, okay, look around, search about. Hopefully it's not that hard to find. If they're actually doing things right, it'll be super easy to find, right? So you can say, okay, is there a disclosure program? Are there contacts available? And then you just follow through the process, super easy. Luckily, in our case for this one, that was the case. Can't find that? Look around, try to find contacts for the security people, right? Anything to do with security or technical people. If you can't do that, the last thing we've done is go straight to the social media, right? It's like, I surprisingly get more replies from Twitter than I do anything else. Like, you can blast their emails all day, but they'll reply to their Twitter account. All right, so once you get a hold of them, okay, you start this process. You say, hey, I've got these bugs. I want to talk to you about them. I want to figure out how to walk through this and actually get them fixed for my customer. What's this look like typically for us? So usually we'll put together all the details we can as much as possible. If you have the ability to show them code and actually point out exactly where the bug is, do it. It's going to make it a whole lot easier in the end. Sometimes they're going to want possible solutions. They might not listen to you, but that's fine. You can give those if you want. And then a lot of times we'll actually start putting in disclosure timelines. So places like, Google and others have kind of set a standard. Okay, this is 90-day disclosure. We're going to try to fit, that into your schedule. So we usually kind of put that out there and say, hey, this is what we'd like to see. Because in the past, we've had companies where you put it out there and they just say thanks, and then you never hear from them again. They never patch it, and the end, right? So we can't have that because we're doing this for a customer and our customers want to get it fixed too. And then the last thing here, if the people don't actually have a program, they don't have a disclosure process, a lot of times they say, okay, yeah, we'll fix these, but how do we actually get these out to everybody? And so what we found is if they aren't a CVE, registering authority, you can actually go to MITRE directly and say, hey, look, all right, we found these bugs. These guys don't know how to do anything with it. So can you give us some CVEs? And they will. And then you basically just work the process. And when they're ready to disclose them, you just tell them and they put them out on the internet and it's taken care of. All right, so bringing it back to this particular instance, this was for Siemens. Luckily, the whole process with them was super great. Like, they were very professional, timely, receptive. Went through the whole process with them. They patched everything up. They actually just put out a release last week or so. They actually had a patch for these, issued 7 CVEs for it. So we were super happy to work with them. Looking forward to it again, hopefully for us, hopefully not for them. But yeah, that's kind of the end of the story, and it was a good one to end with. All right, so that kind of sums it up. If y'all have any questions, I'll field whatever you got.